This is Shakil Ahmed. In today's tutorial, we learn how to calculate sample size when we are going to detect a significant difference between two population means. We assume here that the two population variances are equal and the sample sizes from the two groups are taken same. For sample size calculation, we need again to go to the web page of eptool.ausvet.com.au, and from sample size calculation tab we select the option of to detect a difference between two means. Then we need to enter the following inputs. The first one is mean in population 1 and mean in population 2, and the variance, which is the combined variance for the two populations, and the confidence level, which is usually taken as 0.95, as we take the 5% error, and the desired power is taken as at least at zero point 0.8. Even for some cases we can also take zero point 0.7, which is low power for detecting the true null hypothesis, or for making a correct decision. So the inputs are, as we already discussed, true value for the two means, and the desired value of confidence, and the desired power for the detection of a significant difference, and the estimated combined variance. And by default the calculations assume that a two-tailed statistical test will be used, but a one-tailed test can also be specified if preferred. And we discuss an example. Suppose you want to compare two methods for treating cancer. Your experimental design might be as follow. Select a sample of patients and randomly assign half to one method and half to the other method. The two methods are the groups in which different methods are applied are the two populations. And after 5 years, we take or we determine the mean BMI in each group and test whether the difference in the mean is significantly different from zero. So the power calculation assumes here that the two random samples are drawn from two separate populations. So we conduct this calculation in EP tools. So I will share the screen where we calculate the sample size. Here we select the option of two means with equal sample sizes and equal variance. If you have unequal sample size and unequal variance, then you need to select the second option. We can also see the second option as well. So this is population mean for first group, and this is population mean for the second group, and this is the combined variance. These all the inputs are uh, arbitrarily chosen or uh, using some expert judgment, and these inputs are also can also be taken from previous studies for same population or for same setting. And the confidence level is 0.95. Usually we take 0.95 as a 5% error, and the desired power is 80% for usual statistical tests. So we opt for a two-tail test, or we can also opt for one-tail test, and then submit. You will see the required sample size for the two groups. These are the inputs we entered, and the results are four and total four for each group, and eight as whole as there are four in both groups. You can also choose the option of different variance for the two groups or for two subpopulations and unequal sample sizes. So we need population mean for population one, mean for population two, and variance in population one and variance in population two, and in 95% confidence interval. Now we need four things instead of three things, as the variance in population one and population two are different. So the sample size will be differ as the ratio of sample size is taken as 2, but you can change the ratio of sample sizes. And then okay, these are the inputs we entered, and the outputs are 5 in each group as the ratio of sample sizes are taken as 1. If you want to select more units from group 2, then you can take this ratio greater than 1. If you want to take larger size in group 1, then you can take the ratio as point or in point something or less than 1. So these are all about the uh, sample size calculation for detecting two difference in two population means. If you have any query regarding sample size calculation in detecting two population means, you can write or you can ask in comment section. We try to make clear in comment section as well. Thank you.